Okay, well, the good news is once you figure out how to solve one three equation, three unknown system, you can do them all because the principles are the same for every single one of these problems. The tricky part is there's an infinite number of right ways to do this. And I think having kind of all that freedom as to what to do first messes up students. So I always advise people to take the easiest, laziest path you can on these. You want to do as little math as possible. Um, and so I'm going to look for variations on how I can eliminate variables without having to do very much work. That said, let me talk through this first one and show that we could eliminate x's, y's, or z's, and then I'm definitely going to do y's because that's the one with the least amount of work. And the less work I do, the less room there is for me to make a sign error, and that is the bane of your existence for these ones. Is it's all just basic addition and subtraction, but there's so much of it somewhere you tend to make one little mistake and then that carries through the whole problem. So that's why we want to minimize the amount of work we're doing. Plus, if there's an easy way, let's do it the easy way. So I can eliminate either x, y, or z. It doesn't matter, whichever one's easiest, that's the one we're going to pick. But I could pick any of those variables for my first round. The deal is though, like if I decide to eliminate x, I have to eliminate it twice. My goal is to make three equations with three unknowns into two equations with two unknowns. That will make it just like the beginning of this homework, and then we know how to solve it from there. So if I decide I'm going to eliminate x this first round, then I would have to stick with x and eliminate it from a second pair of equations. So for instance, let's say I multiplied this first equation by -1 and I added to this one. The negative x plus x, those would drop out, and I would have an equation in y's and z's. I would call that equation 4. And I'll do a version of this in a second. I just want to talk through a couple of versions that I'm not going to do. So then I had used 1 and 2 and eliminated x. Now I could use 1 and 3 or 2 and 3. So say for my next move, I multiplied equation 1 by -3, and I added to equation 3. That -3x plus 3x, those would cancel. I would now have a second equation in y and z. Then I could put those two together just like we did for the first 15 questions of the homework and solve those. And then we do the back solve like we did a couple of questions ago and go back through the problem. Let's say I decided to eliminate z instead. So I could do -2 to equation 1, and then -2z plus 2z would cancel each other out, and I'd have an equation, and this would be what I was calling equation 4 in the video. Equation 4 would be x and y. And then for my second round, I could multiply equation 1 by 3, and that would give me a 3z minus 3z. I add 1 and 3 together, z drops out, and I have a second equation, or equation 5, in x's and y's. And then again, I could put those two things together and eliminate a variable and get my first solution and then back solve. What would be easier than doing either x or z in this case is the y's, because I have a plus y and a minus y. So if I just add 1 and 2 together as they are, so I will show this, because this is the way I'm really going to solve it. So there's our equation 1, and then here's equation 2. I like this, oops, that's supposed to be an equals. I like this version of the solve better because I didn't have to do any math. When I was trying to eliminate x, I had to multiply this by a negative, which introduced 1, 2, 3, 4 places for me to do something dumb. And that's why the less math you can do here, the better it is, because there's fewer steps. So now I'm going to add these together. We always rewrite it as addition, so we always want the same coefficient for what you're trying to eliminate with opposite signs. So we go x plus x would be 2x plus y minus y. That cancels. That was the plan. 1z plus 2z's makes 3z's. -1 plus 5. That would make positive 4. And again, I'm going to call that one equation 4 just so I have something to refer to it by. And then why I like the y's a bunch is because now I can just do equation 1 plus 3. So I did 1 and 2. So I could do 2 and 3 or 1 and 3. But I'm going to do 1 and 3 because, again, I don't have to do anything to it, plus y minus y. So that's the easiest math I have available. Let's scoot down here so I don't run myself out of room. So we're getting to equation 1, x plus y plus z equals -1, and equation 3. 3x minus y, and there's that same coefficient opposite signs we want, minus 3z makes 9. So this is going to be 4x, the y's drop out, that was the plan, plus z minus 3z's would be minus 2z's, and that equals 8. And I'm going to call this one equation 5, again, just to give it something convenient for myself to reference it by. So now what I've done is I've taken two equations, I've put them together, I've made a fourth equation. I've taken two different equations, I have put those together, I've made a fifth equation. And 4 and 5 need to have the same variables, because now I'm going to eliminate x's because it looks easier than the z's. But you put 4 and 5 together and you eliminate one of the ones that's left, and that gets you your first answer. Once you have that, you can come back to 4 or 5, plug it in, get your second answer. Once you have that, plugging it into 1, 2, or 3, get your last answer. So that's why it's super important. Once you eliminate y in your first step, you have to stick with it. It doesn't matter which letter you pick, but you have to stick with it. So let's do, I said x looks easier because I could do negative 2 times equation 4, and that will get me a negative 4x, and this one has a positive 4x. I could have done the z's, but then I had to done this one by 2 and this one by 3, which again just introduces one more spot for me to make an error, so I try to do as little math as I can. So negative 2 times 2 is going to be negative 4x. Negative 2 times 3 is going to be negative 6z. Negative 2 times 4 is negative 8. And then equation 5, we'll bring that over. And for that I got 4x, and so there's that same coefficient opposite signs again. Minus 2z makes 8. Okay, so then those drop out. This would be negative 8z. Oh, okay, that's cool. It equals 0. And if I divide that negative 8 over, what that means is that z equals 0. It's not like it's inconsistent or anything like that. It's just literally that value is 0. So once I know that z is 0, I got my first answer. Now I can go back and back solve. I can go to either equation 4 or 5. I'll arbitrarily pick 4 here. So 2x plus 3 times 0 would just be 0 equals 4. So 2x equals 4, so that means x equals 2. Now I got my second answer, and I could have put that in here as well, right? Because then I got 4x equals 8, and x is still 2, so there's no wrong choice. And then you come back to either 1, 2, or 3, but any of the ones that have a y in it. Equation 1 looks the easiest, so I'm going there. And so we know x is 2. We're trying to work out what y is. We know z is 0, and that equals negative 1. So y plus 2 equals negative 1. y2 looks like a z, but that's a 2. So subtracting that over, I get y equals negative 3. So for this one, it looks like we got x was 2, y was negative 3, and z is 0. And if you feel like checking it, you can. You can just take this ordered triplet right here and plug it into either equation 2 or 3, actually even both of them, and then that on this one it should come up to 5, this one should come up to 9. So that is the basic plan for solving all of these. To recap that one more time, and then I'm going to do some examples here with a question I have up. Our goal is to eliminate the same variable twice to make equation 4 and 5. So we look at what we got, and we figure out what's the easiest thing to get rid of two times, same variable though. We do that, we get equation 4 and 5. We put 4 and 5 together, we eliminate something, and then that gets us our first answer. We take that answer, we go back to either 4 or 5, we plug it in, we get our second answer. We take our two answers and we go back to 1, 2, or 3, and then solve for that last one. So, where did I put it? So here is, I think this is question 20 off the homework. And so I'm just going to talk through, if I was looking at this, what would be my first move? Like, how would I get started? How do I decide what's going to be my 4 and my 5? Oops, and now I've lost it under there. Okay, let me make that a little bit bigger. So if I had this problem, I would probably do the y's. I could do, let me talk through all the ones I could do. So I could do a negative 2 to equation 1 here. That would give me a negative 2x. I could use it to eliminate this in the first round. I could use it to eliminate that in the second round. That's not bad. If I wanted to eliminate y, I would put 1 and 3 together because then those would just drop out. And then I would probably multiply, you could multiply this one by negative 3 to get positive 3 plus 3, or you could just do this one by 3 and do positive 3, negative 3 there. And then if I was going to do this, I could do like a negative here, eliminate z's there, and then I could do multiply all this by 3 and eliminate that second z. But I'd probably do the y's where I knocked out these two first, 1 and 3, and then just go back and multiply this one by 3 and knock that out again. So let's see if I do a new version. That's super similar. Okay, so let's say we had that. Kind of the same idea. I could just do this by I could do this by 2 and go plus 2 minus 2 there, and then do this by negative 1 and go negative 1 plus 1 there. And kind of the same thing with the z's. So this one doesn't have like any that are like super easy or super hard. Let's see if I go to question 21. So if I had this one, I would probably do those z's right there. So if I just multiply, and yeah, I would totally, because look at all those negative signs. I would just multiply that by negative 1. I'd have 1x plus 4y plus 3z equals 6. And then I would use that to eliminate the z's twice right here. Let's see if I do a new version. See, I don't like that because that would be hard to try to make all those be the same thing. Same thing here. This would be totally hard because I would have to like make these 6 and then multiply that and make them 4. I would probably do x's on this one, so I could do equation 1 and equation 3 is negative 4x plus 4x. Those would drop right out. And then I would do this one times 2, and I would have negative 4x plus 4x. So I think on that, the x's would be the easiest. Let's see, on this one, none of them are super easy, none of them are super hard. I would probably do x's just because they're all about the same. So if I did a negative 2 to equation 1, negative 2 plus 2, that cancels, and then I would do 3 to equation 1 and cancel out that x and solve from there. So on this one, I would probably do the y's. If I do 1 and 3 together, they eliminate. And if I do negative 2 to this, negative 2 plus 2, those would eliminate. And you can see for all of those, I'm just figuring out that first step to get my 4 and my 5. And once you're there, you're back to what you just did on those first, dozen or so problems where you're just solving the two equations with 2 unknowns and then doing the back solve. So hopefully that helps you see kind of how to approach them. And like I said, it's all the same work. You're going to make a 4, you're going to make a 5, you're going to put them together, eliminate one more variable, and get an answer. Like the process is the exact same for every single problem. But the key is picking the easier road to go down rather than maybe the harder road to go down. So hopefully that helps.